and you're good to go.
All right. Thank you, Jordy, for the invite. I'm happy to be here. Welcome from North Carolina, over here in Raleigh. But I'm happy to make the hop across the sea and get to know you folks. Yeah, again, I'm going to talk generally about how Git handles scale, but specifically the way that our team has handled it with the tool called Scalar. Speaking of my team, I'm talking about a lot of people from GitHub. So you've got me over here on the left, but also the rest of the Git fundamentals team is critical to making this happen. We used to be called the Git client team, but we kind of focus on Git and scale at a larger scope than just the client. But also the Git contrib team and the Git systems team have contributed things that have been really impactful at GitHub and are mentioned in this talk. So I have some things. It's kind of difficult to do, a bunch of question and answer during the talk. So I've got a bunch of call out questions like this to, kind of spur the discussion that we're going to have after. So think about these questions as you're going along, and maybe they'll also make you think about what I'm talking about a little bit more in specifically your situation. So again, I wanted to talk about the idea of this product called Scalar. It is a tool that helps you set up monorepos or large Git repositories, and it uses really a lot of opinions about which Git features are the best to handle that. We do have clients available for Windows, macOS, and Linux. So that's something, no matter what your platform is, we probably have a solution for you. If Linux is always difficult to say, like, here's the one way to make it install on Linux, but at the very least, you could always compile it on Linux, and it is supported. The important thing that we've always said since we announced this over a year ago is, like, we want to make Scalar do less by making Git do more. And so definitely when this first came out, it was a .NET project that had a lot of stuff in it that was doing things that Git couldn't do yet. And you could find it at our GitHub page, github.com/Microsoft/Scalar. A lot of people on my team are transplants from Microsoft into GitHub. So that's a part of the reason why these names are like that. But also right now, it is no longer there where you would actually get the software. You actually want to go to our fork of Git, github.com/Microsoft/Git. And because we've taken enough things out of the Scalar project and into core Git itself, that we were able to just port the Scalar command line interface into the Git code base. And we've got it available in our fork right now. We're working on getting it into upstream Git and seeing how the community thinks about having that in the core Git code base. If you want to install it, there's different ways for each platform. So you can see how to do it on Windows, macOS, or Ubuntu. But also all these instructions are on our README on the github.com/Microsoft/Git. So I'm not going to let you write this down very carefully. Just go copy paste if you need it. So I want to take a quick spin around a different view, which is to let's step back from what Scalar does and kind of talk about what motivates it. And at the very end, I'll wrap it up with, like, okay, here's how Scalar fits all these pieces together. And the main thing I want to think about is, how do monorepos grow? Right? If you start a repository, you start a code project, it's not going to start with millions of lines of code. It's going to start small. Maybe you're pulling a few things in, and you got hundreds, maybe tens of thousands of lines at the first prototype. And as you start building more features or making it more advanced, it starts to grow larger. And then you start adding more team members, and then they start getting involved and accelerate how big the repository grows, and continues to evolve until then it becomes this unwieldy monster. And that's what we want to avoid, being in the situation where we're too stuck. And it's like suddenly we're too big to be able to handle things. And it's during this growth that you have agency as a developer about how do you create your repository? How do you direct its growth to be scalable? So one thing I want to ask you is, like, how big is your repository? What's the main thing you're working on? And how big is it? Is it actually causing problems with how big it is? And what's driving that growth? Is there something you can identify in terms of, oh, I've got certain files that are big, or we just got a lot of people working and we just create a lot of commits or something? Whatever it is that's driving your growth, I want you to think about it and see how maybe it's worth changing. The other thing I want to keep in mind is, like, if you're in a Git repository already, then if you're really small, you're just happy right now because Git is really fast. everything gets good. Even as you start growing into a medium-sized project, Git does a really good job with all the default configuration to make everything work. But as you get to be a really large project, you start to kind of push up against the boundaries of how Git is designed and what sort of things are kind of causing you some pain points as you're getting there. And then when you get to really giant growth, you're kind of breaking out on the boundaries, and certain things just don't work the way you expect them to. And we want to avoid this scenario, but also our team is working really hard to make sure that just that size of the Git project itself can grow to be this size. But in the meantime, there are tricks we can do to kind of shave off those pain points. The other thing we want to think about is, what if you were starting your big monorepo in a different version control system, and then you want to migrate into Git? Well, that same idea of, as you're growing, you actually fit the shape of your container in some way. So depending on how your old version control system worked, maybe certain things worked out really well. The canonical example is if you have a lot of binary assets in Perforce. That Perforce is built for that scenario, but Git is not. This is particularly meaningful to our team because we have 2 teams that we support that have migrated to Git or in the process of doing so. And that's the Windows operating system code and the Microsoft Office code. These are 2 big monorepos that actually were built via a fork of Perforce. And in fact, they had different forks of Perforce that they built for their own scenarios. Windows in particular had a version that virtualized the file system, so that way you could connect and download things in a different way. And that allowed their build system to not need to tell the version control system how it was working. And the build system would just discover which files it needs, and then the version control system, through its virtualization, would kick in. Yes, and Source Depot is the name of that fork of Perforce. Thank you, Paul. While Office, they didn't put that virtualization layer in their version. Instead, they worked on componentizing their build system and then saying, oh, well, I only need this small piece of my of the monorepo in order to do my builds and my work. And then I can contribute to the piece without having to have the whole thing viewed in that way. And so these 2 different approaches are actually changing the way that they translate into Git. For Windows, they still need a tool called VFS for Git, previously called GVFS, which has that virtualized file layer, but underneath Git. Office, however, that wasn't necessarily the best approach for them. And we found that actually there's some core Git features they could depend on instead. And by moving that way, they are now unblocked to do more dependence on Git and not be locked into the VFS for Git model. If Windows wants to get out of VFS for Git, they have to change things in a more dramatic way. And so we're working to that. So one thing I want you to think about is how can your build system and things like that work with these features I'm going to talk about in order to make sure you are taking the most advantage of what Git has to offer. So I'm going to break down the idea of how Scalar helps this scenario into 4 big categories. The first is it reduces the amount of data transfer, how much time we're spending in clone, fetch, or pull. Then it reduces the cost of scanning the working directory, how much time it takes to run a certain Git commands based on the number of files you have in your working directory. It also reduces the scope of your working directory and helps you focus on only the files you need, which it builds on to the other 2 points. And finally, it reduces the cost of keeping data organized. So let's take these one by one. Let's talk about data transfer. So is data transfer a problem for you? So are you frequently blocked on clones, fetches, and pulls as being one of your big pain points or a bottleneck for your productivity? Then this category is going to be very valuable for you. So this is my visualization I like to use of the Git object model. At the top, we've got a bunch of green circles, and these represent commits in your history. So they point to other green circles showing those are their parents, and so you could do a Git log, for instance, to look at the commit history. Each commit has a single root tree, which represents the directory right at the base of your working directory if you checked out that commit. And those trees can point to other trees, which are other triangles, or these red squares, which are representing blobs, which are file contents. So directories point to the file contents. The trees themselves contain the names. So this is kind of the picture of everything you need in order to work with a Git repository. And out of the box, Git, if you want to have a commit on your machine, Git says, well, I need to have everything else it references. Otherwise, if I start doing a command, I might discover something I don't know about. And so it downloads every single reachable object. And that's this whole picture. Now, based on the types, typically we see this on the far left, the ratio by number, by count. There's literal count of commits, trees, and blobs, this sort of thing. But blobs, being your code files and things, frequently are larger than trees. And so in a really well-maintained repo that's only source files that diff really nicely, this middle blob is kind of like this middle column is how much data you expect your repository to be taking in terms of blobs, trees, or commits. But in extreme situations where you have, I may have maybe a bunch of image files, or I have a bunch of really big source files or data files that don't diff well, then your blobs can actually take a much larger portion of the data on disk while still being relatively the same as the ratio by number on the far left. And so there's lots of scenarios of how to solve this, including things like Git LFS. But if you actually want to do it just using Git, there's a way we can actually reduce the amount of blob data we need to transfer using Git features alone. One way to discover if you're in this situation, though, is to download the Git Sizer tool and run that on your repository. It's available on github.com/github/gitsizer. And it'll list a bunch of metrics about your repository and tell you which things are painful, which things are something you should be worried about, and give you some nice stats too. So go ahead and play with that on any of the repositories you've been playing with. So again, we're looking at this picture. I've got the commits, trees, and blobs. So we're trying to say, how can I reduce the cost of getting this repository without having to rewrite history and change my whole repository? Well, Git has a feature called partial clone, which you can just set up when you're initially creating your repository. You can run git clone and then add this extra option, -- filter equals blob : none. And this says, please give me a blobless partial clone. Now, this doesn't mean you won't ever have any blobs. It means that that initial request says, please give me all the commits and trees, and then I'll get blobs as necessary, only the ones I need. So one thing I want to point out is that partial clones are available on github.com and GitHub Enterprise Server from 2.22 and beyond. So if you have repositories you like that are on other of those environments, you can go ahead and try this out and give it there. This is a relatively new feature, though, so it's only been out for about a year and a half. So in this view, again, a full clone has all commits, all trees, and all blobs. But if I did a partial clone, I actually can see that I initially download the commits and trees, and then when I go and check out the tip commit, it goes and gets those blobs that I need for that checkout. So it'll get all the red boxes in this gray box on the right, this head, but throughout the history, those blobs I don't actually need. And when you're in a very large repository and most of your files have been edited a lot of times, the vast majority of files are actually just in your deep history. And so you don't need them in order to do your work at tip. Now, if you do something like run a diff against an old commit or run git log or git blame, those might populate blob as you need them to do that work. However, it's usually the stuff that you need for your focused work, and you only need to do a very small subset of that. And the more you do those commands, the next time you run them, it won't need to download them because it already has that data. So this is kind of how we can reduce that data transfer significantly in some cases. One thing I want to point out is there is an old concept called a shallow clone, which means, oh, please, I only need this tip commit. I don't need all that history stuff. And it can greatly reduce how much data you transfer because you don't need all the trees in history and all the commits in history. However, in this scenario, Git doesn't work right? It doesn't work the way you expect for a normal repository. You can't run git log because your commits just stop. And if you try to work forward from this scenario by doing fetches, your fetches are going to be really slow. So generally, this feature is only useful for, say, you're doing a CI build on a VM, and after it runs the build, it just deletes the repository and never uses it again. This is a great way to reduce the data transfer for that, but it's not a good way to work for a developer trying to do meaningful work on a repository. So that's one thing I want to keep in mind in contrast to that. So after you've reduced the amount of data transfer, let's talk about the amount of work Git really needs to do in order to help you out. And I want to think about, are you frequently waiting for things like git status or git add to complete their work? This whole category is about why these things might be slow. So one thing to think about is optimizing your working directory. If you think about focusing on this picture, let's just focus on a tip commit and how its root tree spreads out the files in the working directory. These files are all the ones that Git tracks. So it's all the ones Git knows about, but it's not necessarily all the files that might exist in the working directory. So if I just created a new clone and I have this working directory, this is what it looks like. But then if I run a build, maybe that spits out a bunch of .o and .exe files all the way through my working directory. And these are all files that are new and they exist and they've modified all my directories. So all the directory M times are new. So Git comes along and says, hey, I want to find out what's new. You said Git status. Let's see what files are new. It's going to have to start scanning directories and say, oh, this directory is updated. These are new files. Oh, wait, they're all in my .get ignore patterns. So I'm not actually going to care about those, but I had to look at them first. And then it keeps on going through and going deep and deep and deep into your working directory to say, oh, here's all this work I had to do to find out what data was at these files, but I don't actually need to report anything. I'll tell you I have a clean status. And so this sort of work is something that's painful to work on. Now we're working on a feature called FS Monitor to make it such that Git asks for that instead of going and crawling the working directory. But there's a simpler solution you can do for this sort of problem, where it's just like I created a build and that created a bunch of files in my working directory. And that is just get your builds out of the source directory, right? One thing we like to do is to create this sort of a diagram of how Git data works. We have this idea of thinking about an enlistment instead of a repository. It's like, here's my repository, and inside is an SRC directory. And that SRC directory is actually where the Git repository is. And it's got all my source code, it's got the README from the project and all that. And when I run a build in the SRC directory, all of the generated output actually goes into an out directory that's adjacent to the SRC directory. So all of my, files that are generated here go there. And also if I need packages and things via npm or NuGet or whatever, those can go into a different directory as well. So we can still get quick build caching, but we're not populating the Git repository with that data. And so Git, it doesn't need to, like for instance, I can run a build and then Git says, what's the M time of my source directory? Oh, it's older than my last update, so I don't have to do any work, right? So this is a really thing that you can do in your repositories without relying on Git features to make things work a lot faster. And this is what we do with our projects whenever we can, but also like the Office and Windows repositories are set up this way. And this kind of gets us into the idea that why are we caring about Git performance and all that? It's about making sure that we have focused developer time, right? When developers get distracted, they context switch, things are complicated so that they get things out of their head and then they have trouble getting back into it. So doing things like focusing how your builds work can lead to making your developers be focused and can improve your efficiency as an engineering group. So that's something to keep in mind, especially when we think about the next section. So I guess I have this question first. Does your build system promote developer efficiency, and how is it designed to make sure that developers can work as quickly as possible within a larger context? And my general feeling is that when you think about this problem in a really interesting way, like just to say, how can I make sure that developers who are in a small part of the code only need a small part of the code, that improves your build system, which is usually your biggest pain, and that translates over to version control, and specifically the idea of the scope of the working directory. How many files do you actually need in order for a developer to do their individual work, contributing to a larger goal? So one thing that I like to have these kind of pictures is, how does your architecture work in a way that maybe makes your build cones be smaller? So one thing I like to think about is this flywheel architecture. You've got some core code that every single little service needs that's in common. But if I'm actually going to build just one service, maybe I only need to contribute the things that are special to my service. And I need that core code to build, but I don't need the code for all these other services. And specifically, you can have these idea of contract and implementation boundaries. So maybe my service depends on 2 other services, but I only really need the contract. I don't need their implementation in order to make sure that my service builds, compiles, and I can run initial tests. I don't need those services in order to do all my things. Let the integrations between them be checked at PR build time or CI time on somebody else's machine, not my machine, right? That's the reason to keep it in a monorepo, is so that way you have all these things working together in tandem, and you have a test scenario that works for all of them. But you don't need your individual developers to be paying that cost in order to do their work. They maybe need it to debug something, but primarily the happy path, they don't necessarily need it. Now, when you have this idea, we can take advantage of Git features to speed things up. So initially, if you think about, oh, I get my Git repository and I've got every single file in the working directory, that might be hundreds of thousands or millions of files. But if you're able to have this idea where your architecture allows a developer to only build a small cone of it, then maybe you can tell Git, hey, you know what? This is the cone I need. Ignore those files over there that I don't really need. And so we can do that with a sparse tree to say, here, these are the paths that I care about. Everything outside of that, let's just not worry about. Let's not put them in my working directory. Let's not track them. And now my working directory could be a lot smaller, right? I could be in a repository with millions of files, but only care about tens of thousands. And let the CI builds and things like that handle the millions case for the really large builds. And this is using this Git sparse-checkout feature. And so there's a very basic usage of this command. If you want to get started, you go git sparse-checkout init. And I like to go -- cone because it gives you an idea of focusing on a directory-based pattern set. And so the rest of this is expecting that. You can do git sparse-checkout set. And you say, here are the directories I care about. And it'll give you everything that's recursively inside those directories, but also along the parent directories to those, it gives you every file that's adjacent. For instance, by default, it's just the files at root and nothing inside a directory. And you can also do git sparse-checkout add to say, well, I need this extra directory. I didn't realize I needed earlier. And you can disable it to get you back into the state. And we've got a blog post here that I've linked, but you can find on the GitHub blog that talks in detail about how Git sparse-checkout works, and specifically how cone mode accelerates some of the stuff that Git is doing under the hood. So one thing that's really nice about doing a partial clone with sparse checkout is that the features really mesh well together. So if at the bottom I have here git clone -- filter equals blob : none, but also -- sparse, saying, okay, I want to download all the commits and trees, but then I'm going to check out head. And initially, I only need the files at root. All the other files are not actually present. This is a much faster situation to be able to get started. And then you can do the git sparse-checkout add to actually say, give me the files I need in this specific cone, right? And so after I've added these files, okay, just go get those files I was missing, put them on disk, and ready to go. And now as I move around the history and things, I'm not getting the entire tree. I got this much smaller set of files. So this again accelerates that these two things work really well together. So the biggest thing I see when I say, hey, you should use sparse checkout, it's really great, is that it's difficult to make sure your build system is actually organized in a way that it can use it. And what is the relationship that we can do to connect it? So if you think about your scenario in your life, how does your build system work? And again, if you're focused on being able to have a developer build a small subset in order to do their daily work, how does that connect to being able to use something like sparse checkout? And so this is something I like to say is like, this is not a problem we can solve alone. This is not something that Git itself as a project can solve. People who are working on build systems of different flavors can really come together and try to build things that connect the build dependencies in their system and integrate with sparse checkout. And so I'm looking forward to advancing these sorts of things. I want to build an example one for myself in one of these systems. But I think that this is going to be the next breakthrough if more people adopt it. For instance, Microsoft Office has their own thing, but it's based on their own custom build thing that isn't applicable to most public projects. So we want to be able to move this forward. And then finally, the last thing I want to talk about that Scalar touches on is keeping your data organized. And so I want to mostly talk about the fact that there's two different kind of data types that are in your Git repository. And this is stuff that's inside your .git directory. So first off, you got your references, which is like your branches and your tags. These can be loose, which means they're just referencing by the name of the file they're in, or you could be in a packed file. You can also have your loose objects, like those commits, trees, and blobs. When Git initially creates them, they create them as loose objects. But then later they get packed up into things called pack files, which are much more efficient. That's also how you get data from your server by downloading a pack file. And those pack files are actually paired with things called pack indexes. I call this all the primary data, because this could be the only reference of a certain object or a reference that you need. But then you got a bunch of secondary information that's in there. For instance, your ref log showing you how your refs have changed over time. But also there's a commit graph file that gives a compressed view of your commit history. And there's a multi-pack index that if you have multiple pack files, you can use a multi-pack index to quickly seek into those pack files. But you can also delete it, and your pack indexes will suffice, just be a little bit slower. So these are more like helper data or performance related things. The one thing I want to think about it, have you ever been blocked when you've been working and you're just like, I just want to git commit, and then suddenly you're waiting, git GC auto is happening, right? And it's in the process, you're just like, I want to get my work done, but I can't because this thing hasn't finished yet. And this is the sort of frustration that gets even bigger and harder the larger your repository becomes. So the old way of maintaining your Git data is that some Git commands would run git GC auto as a sub-process at the end of its operation, right? Git commit would just say, hey, run this. And it always runs it. And then git GC auto says, hey, has it been long enough since I did a GC or a repack? And if it did, it's say, okay, let me go do a repack. And it would completely take all of your Git data and pack it up into one really compressed file. But that might be a lot of work to do that. And while you're doing it, it's kind of blocking other commands. First, it's blocking you from being out of your command line, but also it's not a terribly safe thing to be doing the way it deletes files and re-adds them. So it's not really safe for concurrency. So the new way is this thing called background maintenance in Git. So there's a background schedule that it runs, and it runs this thing called git maintenance run -- schedule equals X as appropriate. And the X means it's either hourly, daily, or weekly. And these different schedules run different workloads. And then all of these operations are actually safe for concurrent Git commands to be run. And this is a feature that really makes it so that you don't have to run git GC auto ever again. You can rely on this, and your repositories will be in a nice, clean state. Here's a basic idea of how you work with the Git maintenance. You can run git maintenance start, and it just says, okay, my repository is going to have background maintenance run now with the default strategy. You can also run git maintenance register, which says, please enlist me in the list, but don't actually start it. Unregister says, okay, take me off the list, but don't stop other people from enjoying it. While if you really don't want background maintenance to be running on any repositories, just run git maintenance stop, and it'll turn it off. And you can really customize how the maintenance works using the git config maintenance.star, whatever maintenance values are there. And so you can look at the docs for details on this, and also the git config docs for what are those options. So the by default, git maintenance start does a bunch of things that we recommend, but they're not actually, like, you can customize them if you want to do something different, including like how frequently do they run. So let's get us back into this world of how does Scalar help these monorepo scenarios. First, we talked about the data transfer. Scalar will help you initialize into a partial clone scenario. It reduces the cost of scanning the working directory by, it actually creates that source directory by default. And it also has some other things that will help in future versions of Git. It also reduces the scope of the working directory by focusing on sparse checkout by default and allowing you to enlist in the things you care about. And then it reduces cost of keeping data organized by automatically putting you into the Git maintenance, the background Git maintenance. Now, the other thing to keep in mind is that things like the background maintenance and Git sparse checkout, those things existed because of Scalar, or at least in the way they do today, because they were for us creating the Scalar product. So a lot of these contributions are there. And specifically, the background maintenance was one of the biggest things that required our .NET project to like create a service and do all sorts of stuff that now Git handles for us. And so that allows us to reduce how big Scalar is. So now let's actually talk about, like, you want to use Scalar. What does it mean? It's very simple. I can run Scalar clone on a URL, and it'll do the following. It will create your repository in some repo name /source, right? The repo coming from the end of your URL. It'll also default to using partial clone, run the filter blob none on your filters. It'll default to using sparse checkout in cone mode, and it'll set up background maintenance. So in one command, you get all of these benefits, and you didn't have to think about it. You don't have to remember it. You could forget everything I said today and just say, oh, that Scalar clone thing is going to handle it for me, and I'm happy. And it'll also do some more detailed things I didn't get to talk about, which is initialize some recommended but advanced config settings. Like if you're really an expert, you look at the Git config page at every Git release, and you can see what are the latest features I could turn on but are off by default. Or you could just trust that we do that very carefully. And sometimes we're the ones creating those features and saying, you know, if you're a big repo, you want to have this on. Even if it's an old feature like index v4 is a really great thing to have if you're a big repo, but it's not on by default. We turn it on for you. A related command that you might want is scalar register. So if you don't want to create a brand new repository, scalar register will do similar things. Well, it won't actually do those first three. It won't create a repository. It won't default to partial clone because you already have created it. It won't default to using sparse checkout because, again, you've already created it, but it will do the setup, backup, maintenance, and initialize that advanced config setting. So you could try scalar register on your existing repositories, and you should just notice either nothing or, hey, my fetch times are faster, or I don't see my Git GC auto getting in the way. And so you can have these are the two main ways of interacting with Scalar. And then you kind of you set up a repository this way and you forget about it. And then later when you update a new version of Scalar, it will update the advanced config settings as necessary if there's something else that has come into a new version of Git. So that's the primary thing. There's not much to it, really, once you get down to it. Oh, I inserted this in a weird place. Okay, this slide is all in the wrong spot, but forgive me for that. The maintenance schedule that comes in by default, we have these things. Let's not worry about that too much. So I'm almost done. I know that Jody's probably going to interrupt me here, but if you use these,
go.
Okay, if you use all these features, whether you use it with Scalar or you use them because you know about them and you're doing the direct Git commands, then you are at the forefront of Git at scale. Like, I can't tell you anything else that you're missing about using the best Git features you could possibly be using and be best set up to be using monorepos with Git. So, however, Git is a moving target, right? People keep contributing things to it. It keeps getting better. And maybe this means that there's more things that you need. Again, if you use Scalar, you can take our recommendations as they evolve. But also, if you want to learn more, if you want to make sure that you are on top of things, I can't recommend anything more than looking at the GitHub blog. Subscribe to it on RSS or keep an eye out for it on Twitter. We've talked about almost every single thing I've talked about here on that blog post or in blog posts of that kind. So you can look at there for a lot of examples, or you can read more in depth about the things I've talked about today. So go ahead and look at github.blog. Unfortunately, searching for Git is not really helpful because a lot of the posts include the word GitHub, but keep an eye out for those things in the future. And so I thank you so much for your attention. I really appreciate everything, and I look forward to having more discussion. You can find me on GitHub, on Twitter, or at my personal website. Thank you.
Thanks so much, Stolee. I've got two comments before we jump into questions. One is for Jeff, Julia. Well, Jeff and Adam less so because they joined late, but you basically joined almost at the time that Stolee started. But Julia, Matt, and Jameson, hello. Just bear in mind that we've recorded this and we will upload it somewhere. I know that Ed will help me out with that. So the whole presentation is recorded and you will be able to go through it at your convenience. Derrick, Stolee rather, I think I told you before, but I did reach out to the Bazel, how you pronounce the build system that Google develops and maintains, about the call to action that you mentioned. And they actually sort of like told me that this might be a good talk for a future BazelCon. So I'll insist to the person that I talked to at Google about this. And if there's a legitimate interest, I'll let you know. And hey, maybe there's another chance to talk about Scalar this time at BazelConf, which I'm not sure when's the next one, by the way. And I actually, by the way, what would be the best way that anyone here using Scalar for the first time could provide feedback? Or is there any other way, is there any specific way that you and your team would like to know about Scalar usage?
Yeah, we would love to hear if you have any issues with it. You can drop in on our fork of Git and create an issue. Everything's open source. We work in the open. So if you put the issue there, we will be looking at it. We will be keeping an eye for it.
Okay, I've got the first question actually. Did Scalar clone, I'm not sure, I think I checked in the past, and I mean, probably a year ago, even more, but does Scalar clone tell you what it's doing in the background in the command line? Once you've run it, does it say, hey, I've defaulted to sparse checkout, I've defaulted to partial clone, or is this Is this not specifically said in when the command is run?
Yeah, we don't want to make the output be too noisy, so it's not telling you all those
Okay.
things. It's kind of an expectation of if you're running Scalar clone that you kind of want these scenarios. And there's options to do things like disable the sparse checkout initially. Like there's an option for Git clone or Scalar clone to do that. But it does take out the guesswork and the idea that if you're adopting this, especially as a large group, you're kind of expecting people to be in a scenario where this is now the way we get our code. We initialize our repositories this way, and then we run these following steps.
Yeah, I love it. It's convention over configuration in a way, and in a good way. Okay, so does anyone want to voice any questions anytime? You don't have to activate your camera. Paul, do you wanna speak out that, or do you want me to do it for you?
Coming off mute being the challenge. So many of us are stuck using Azure DevOps. Maybe wishing we were using GitHub. But there's a relationship, of course. Do you know if any of the Microsoft folks are interested in deploying the same technologies to the Azure DevOps provisioning for Git?
Oh yeah, so that's one thing I didn't mention. If I knew Azure DevOps people were going to be here, I might have added it in. But for instance, Windows and Office, they are using Azure DevOps for their source control hosting, and Office is using Scalar. So how does that fit in what we're talking about? Well, the biggest thing is that partial clone isn't implemented on Azure DevOps, but Scalar, and specifically our fork of Git, has a way of interacting with the GVFS protocol, which is the way that we built in Azure DevOps how to do equivalently partial clone. It's a little different here and there, but it's the version of partial clone that works on Azure DevOps. And Scalar clone will automatically detect if you're on that type of a system or not. So it'll say, oh, you're on Azure DevOps. I'm going to set up the GVFS protocol instead of dealing with the partial clone request.
So first-time users might know no difference at all between your perfect world implementation and the one that bridges to the past.
Right.
But some of us are ex of Google and saw the expanding, contracting monorepo. We might be checking off every single sub feature to see whether we have our old life redelivered to us again in ADO.
Mm-hmm. Yeah, I recommend giving it a try. It'll let you know, like, hey, we're creating this. There's extra features that GVFS protocol has, like cache servers that are giving you data locality to, that essentially you run a local copy of Azure DevOps server and configure it in a cup. It's a complicated thing to set up, but it's a feature that's there that we haven't quite delivered the equivalent in the GitHub world, but we're working on things in that space.
And how much scaling have you done for this? I mean, it's a clash of words here, but if Pixar store all of everything they've ever made in a single Perforce monorepo, how much have you chucked in a Scalar enhanced version of Git?
Well, the thing to keep in mind is also what's the difference between source code and Git's designed for source code and diffable files versus very large blobs, which I expect, the Pixar example is going to be an extreme on there. And so if you were to say things like, I've got my large binary assets somewhere else, but then all the code I've ever written for Pixar is in a repository, maybe that could work. The thing is, like, once you put in large binary assets, then other scale factors go in that we aren't ready to handle in Git yet. But things like the Office monorepo has 2 million files at head. It's hundreds of gigabytes in size, and there are thousands of developers contributing to it every day.
Do you know what their commit rate is, the Office team?
Oh, that's a good question. It's definitely maybe Matt Cooper knows since he's on the call. But it's definitely right now they're still in the transition, so a lot of users are still working in Source Depot, which means that the commits that we see in Git are actually translations of known good things over on the Source Depot side, making the transition over. So the number of commits isn't really good measure right now. But I do know that Windows at one point had over 12 million commits over the span of 2 or 3 years. Yeah, that kind of rate is very common.
Adam, would you like to ask a question?
Yeah, I'm on. Am I on mute?
No, you're not. We could hear you loud and clear.
My headset is doing weird things. Then, I'm curious about how this integrates with Git. Like you talked about wanting this to become part of Git proper. So when you install Git on whatever application, whatever platform you're using, you just get Scalar. I really like that. Like the Git user interface is notoriously painful, particularly for anyone who's new to it. So anything that can improve that has to be a good thing. But I can also see a bunch of roadblocks there in terms of like this is written in .NET, and Git, I'm pretty sure, is all C and Perl with a bit of Python.
And Rust, I think, lately.
Yes, I think you're quite right. I'd forgotten that. Thank you.
Oh, don't worry.
And also like back compatibility. I know getting new function into Git is often part of the reason the fancy new config options don't get enabled automatically is because it could break back compatibility.
Yeah, you're absolutely right. These are all tricky things. The thing I can tell you is that when we moved from repositories, we didn't just copy and paste the code. We ported it to C. So we actually get to use a lot of the Git code base as a building block to say like, oh, where's a Git repository? You know, I'm looking for a .git file or a .git folder. Let me find it. Let's use their mechanism for running subcommands, all that. But also we put it inside the contrib directory, which is a place where things like git k and these other helpful add-on commands exist. And so it kind of lives over there. And we don't want to say like, oh, okay, if you install Git, you must get Scalar because now it's in the code base. It's kind of a, if you compile Git, you can optionally compile Scalar. And if you distribute Git, you can decide whether or not you want that. And so we're still working on exactly the details and whether or not that's going to be something Upstream's interested in doing. But that's currently our strategy.
But it's not going to be the case that you just run git clone at some point in the future. We're expecting git clone to actually be doing everything that Scalar clone is now doing.
No. And this is something we've discussed on the mailing list several times, like how, we've got all these different fancy knobs you can turn in git clone, but they're complicated and you have to know about them. How to make sure that there's an easy on-ramp for people who know that they have a large repo. They're okay with things like partial clone, but they don't need to remember, -- filter equals blob : none. How can we get them into that good state? And putting the Scalar code base, CLI, into the contrib directory gives us say, here's an example of one way to do it. And again, we're opinionated. We have these feelings of these are the things we want to do by default. That kind of opens the door for, one, is that sufficient? Is that actually solving the problem enough that we can just recommend that for people who want that? Or does it give us enough of a user base and feeling saying, okay, these are the things we like and these are the things we don't like. We're going to create a new git big clone command that does these things without breaking backwards compatibility, right? Who knows what the future holds, but it's kind of like, this is a way to move us towards a better future.
Yep, that makes sense. Thank you.
Anyone else? Any other questions? Paul.
Those weren't questions. That was just me mashing numbers into a calculator whilst Adam was posing this question.
Bear in mind go ahead.
Oh, I was just going to mention that I think the 12 million commits, maybe it was closer to 3 years, but the other thing that we noticed was that their automated build system was using the ADO REST APIs to create commits at various places during the build. So like every build that ran would create 40 commits or something. That was kind of untenable. So they fixed that. So now that their commit rate is lower, but it's kind of like, that's just if you're giving me a scale target about how many times things get pushed to Azure DevOps and how much commit is in the history of it to track in order to do git log and things. That was all part of the scale that could handle.
Yeah, impressive. Can't wait to use it.
Yeah. The thing I forgot to mention with the background maintenance also is that one of the things that's really cool about background maintenance is that it will actually do hourly fetches in the background. So it will get object data for you So you're never far behind. You don't come back from the weekend to your desktop that's been plugged into the network and say, I want to do my first Git fetch, and you have to wait 20 minutes for that to finish. It should just say, oh, I'll get you the updated refs and you're good to go. Maybe there's a few more commits you need. Then it puts all those refs in a specific place that's not your normal ref space. So that way your local copy of the remote refs doesn't get modified by that. So it's a very helpful thing that really speeds up developer workflows. It's kind of like, well, I just need to get the latest data. I don't care when it shows up. It can show up very frequently throughout the day. And as long as the times when I actually sit down to run Git fetch, I want that to be fast.
Oh, that's very nifty, actually. Yeah.
Don't try and run that on an i3 with 4 gigs of RAM, right?
I mean, it all depends on, if you got an i3 with 4 gigs of RAM or whatever your developer, like, are you going to be okay without background maintenance doing that and actually working with that repository at all, right? It's all about questions of what are your resources and what is important to you. For instance, for me, I don't care if one of my cores is busy working on Git maintenance all day, as long as the rest of the cores can quickly respond to me when I write a Git command. And that's just an extreme scenario.
Yeah. I was thinking of the laptop being on without you working on it. And so with an i3, I mean, like during the night or when you're off. But yeah. Okay, any more questions from anyone? Well, Stolee, that was a pleasure. As always, thanks for doing this. And I'll share with all of you the recording whenever I discover where this goes, probably in our YouTube channel. And yes, see you in the next time then. See you all. Bye-bye.
Bye-bye.
Bye.
Thank you.
Bye-bye.